So let's try out example 2. So Jake decides to travel to Shenandoah National Park for the weekend. Thanks to DC traffic, the first half of the trip took 1.5 hours, but the last half took only 45 minutes. If Jake's average speed is 40 miles per hour, how far away is the Shenandoah National Park? What was his speed for the first half of the trip? And what was his speed for the second half of the trip? Let's go ahead and figure it out. So let's start with part A. How far away is Shenandoah National Park? So let's go ahead and list out our givens under the G. In fact, I'm going to actually write out given for y'all. So I know that the first half of the trip, which I'm going to call took 1.5 hours. So I'm going to say T1 is 1.5 hours. And I know the last half took 45 minutes. So T2 equals 45 minutes. His average speed, so V bar, is 40 miles per hour. So miles over hours. Now, before I do anything else, I want to make sure that all of my units match up. And so my hours go with my miles per hour, but I don't have anything that's measured in minutes aside from my second time. So what I'm going to want to do is turn my second time, transition that from minutes to hours. And I can do that using the equation that there are 60 minutes in 1 hour. So I can multiply that by 1 hour per 60 minutes, giving me 0.75 hours for T2. So now everything is in matching units, and I am ready to write out my unknown. So from question A, I know that I'm trying to figure out how far away Shenandoah National Park is. So when I see far away, I should immediately think distance. So my unknown is going to be distance. Now I'm ready for my equation. So I know that velocity, or in this case, speed, my average speed is equal to my total distance over my total time, which of course is going to be T1 plus T2. So speed is distance over total time. So that means that my distance is going to equal my speed times my total time, which again is T1 plus T2. And I can do that by just multiplying both sides of my equation by T1 plus T2. Now I am ready to substitute and solve. So my sub and solve step. Let's go ahead and do that. So I know that my distance is equal to speed times the sum of my times. So we've got 40 miles per hour, so 40 miles per hour times 1.5 hours plus 0.75 hours, or 40 miles per hour times 2.25 hours. So my distance is going to be 90 miles. So we know that Shenandoah National Park is 90 miles away. Now I'm ready to move on to part B. And I'm going to go ahead and just erase everything that I've already done. Okay, so now I've erased everything except for my guess steps, and I'm ready to look at part B. So in part B, I am trying to figure out Jake's speed for the first half of the trip. So let me go ahead and start listing out my givens. So first of all, the time for the first half of the trip, so T1, or in this case just T, is going to be 1.5 hours, and I know that from the first part of my problem. Second, I know that the distance that is traveled for that first half of the trip is going to be half of my total distance, so 90 over 2, or 45 miles. And that is going to be all of what I know. And again, I know that because it's half of my trip, and my total trip is 90 miles. Next, I need to figure out my unknown. And from the question, I know that I am trying to find Jake's speed. So let me go ahead and give you the equation. And the equation is going to be the same as our previous equation. And that is that. Oh, guys, I just realized I represented speed with an S. Remember, speed is going to be a V. That's something that I sometimes mess up as well. So again, our equation is going to be that your speed is equal to your distance over your time. And we don't have to do anything with this because our variable is already by itself. Our unknown is already by itself. So let's go ahead and substitute and solve. My speed is equal to my distance, so 45 miles, divided by my total time, which is 1.5 hours. And when I do the math, I get that my speed is 30 miles per hour. So the speed for the first half is going to be 30 miles per hour. Now I'm ready to do part C. And again, I'm going to go ahead and erase everything here that I don't need. The one thing I'm going to keep the same is that distance, because my distance for the second half of the trip is going to be the same as the distance I traveled in the first half of the trip, since they are, of course, halves. However, my time is different, right? So the last half took only 45 minutes. So T2 is what we're going to use here. And it was 45 minutes, or again, 0.75 hours. My unknown for C is going to be the same as my unknown for B, and it's going to be my speed, but I'm going to call that V2 since it's my speed for the second half of the trip. And in fact, I'm going to say that this is V1 for part B. My equation is going to be V2 is equal to my distance over my time, and I can substitute and solve in. So V2 is equal to my total distance that's traveled for the second half of my trip, so 45 miles, over 0.75 hours. And when I do the math, what I find is that V2 is 60 miles per hour. And there we go. I have solved all three parts of this problem.